In this video, we are going to tackle about a solids of revolution. So I have a short explanation about a solids of revolution. So it talks about a three-dimensional figure that has a volume, and for the calculating the volume of solids of revolution, we have a given three elements method. So what are those? We have here the desk method, washer method, and the shell method. So these are useful for calculating of volume of solids of revolution. So anyway, I would like to show the example of solids of revolution. I have here the empty solid matter that considered as a solids of revolution because it has a three-dimensional figure, and also we have the volume of this object solid matter. So for now, let's focus only for the desk method. And for the desk method, I have a short description here. So for the desk method, it is useful for the single curve that rotate along the x and y axis, and it has only a one radius. For identifying the radius of the desk method is from the center into the curve is that is radius. And for getting the radius is we need to remember that top minus bottom, that would be our radius. So in other words, the desk method or the desk figure is described as one radius, and it looks like a plate. And for now, we have a formula for the desk method. It depends upon the axis of rotation, because if we have the axis of rotation of is in the x-axis, the volume is given by v is equals to pi times the integral of f of x raised to the second power dx. So why is it dx? Because the function, the integrand here, it talks about the f of x, and the axis of rotation is occur in the x-axis. That's why we need to respect the x. And we have here the a and b represent as a limits of integration. So for the key points, always remember that the radius is equals to the value of our f of x, and the value of our f of x is equivalent to the value of our y. So don't need or don't confuse about that. So for the second case, we have the axis of rotation is in the y-axis. The volume is given by v is equals to pi times the integral of c to d. We have here the limits of integration times the integral of f of y raised to the second power with respect to y. So dy here, because the axis of rotation here is occur in the y-axis, and the function, it talks about the f of y. So that's why we need to respect the y. So for the key points, radius is equals to the value of our f of y, and the value of our f of y is equivalent to the value of our x. So don't confuse about that. So let's move to the exercises about the desk method problem. So we have here, find the volume of the solids obtained by rotating about the x-axis. X-axis, take note, rotating about the x-axis. The region under the curve y is equals to x squared, y is equals to x squared plus 1, and then the interval from the 0 to 2. So let's have a graph of this case. We have here the graph of this case. So the axis of rotation is we have here the axis of rotation is in the y-axis. So the y-axis here, and then it rotate about 360 degrees. So we have here the radius is equals to x squared plus 1 because the y, that would be our radius. For getting the radius as x squared minus top minus bottom, our bottom is 0, so x squared plus 1 minus 0 is equals to x squared plus 1. So that would be the radius of this 2D figure or two-dimensional. So why is radius important? Because the radius is important in order to get the volume of three-dimensional. So for now, we are going to rotate this one from along the x-axis. So rotate this one about 360 degrees. So we can form now a 3D or three-dimensional with the interval of 0 to 2. So according to the given. So 0 to 2, and then the axis of rotation is in the x-axis. This would be the figure of a given problem. So let's have to calculate the volume of this of this figure. So by a given formula of this method, that the axis of rotation is x-axis. So this would be equals to v is equals to pi times the integral of f of x raised to the second power with respect to x. So dx. We have here the e and b that represent of our limits of integration. So we have the value of our f of x, which is x squared plus 1. So always remember that y here is equivalent to f of x. So the value of our y is x squared plus 1. So that would be our f of x. And the interval is 0 to 2. 0 here is the value of our e, and 2 is the value of our b. So let's evaluate the equivalent value from this given formula. So this would be v is equals to pi times the integral of 0 and 2. The value of our e is 0, and the value of b is 2, with the integral of x squared plus 1 raised to the second power, and then dx. So that this would be the value of our f of x. So for now, we need to isolate because of the second power, and this would becomes v is equals to pi times the integral of x squared plus 1 times x squared plus 1 dx. And then we have 0 to 2. So for now, we multiply the x squared plus 1, x squared plus 1. So this would be result as v is equals to pi times x to the fourth, because x squared times x squared is x to the fourth. X squared times 1 is plus x squared, and then 1 times x squared is plus x squared. 1 times 1 is plus 1 with dx, and we have the 0 to 2. For now, let's combine the like terms of our integrand or in this function. So if we have the like terms, we need to combine by adding. So this would be equals to pi, v is equals to pi times the integral of x to the fourth. We have here the x squared plus x squared is, we need to plus this, add this one. So this would be equals to plus 2x squared and then plus 1 dx. So for now, we can get the integral of this function of our integrand. So this would be equals to v is equals to pi times the integral of x to the fourth is equals to x to the fifth over fifth plus 2x cubed over 3 plus x evaluated 0 to 2. So this would be the integral of this function that in our integrand. So for now, let's evaluate the limits of integration, the value of our limits of integration which is 0 and 2 for this function. So for evaluating of 0 and 2 for this function, let's use the principle of definite integral. So if we have here the f of b times minus f of a. So meaning the value of our b 2, the value of our b is 2, evaluate this function. So this would be equals to 2 to the fifth over fifth, and then plus 2x to the 2 raised to the 3 over 3, and then plus 2. So this would be our FB. So minus FA, let's 0 evaluate this function. So if we evaluate 0 of this function, this would be the result as 0. Because 0 to the 5th is 0 over 5 is 0. 0 to the 3 is 0 times 2 is 0 over 3 is 0 plus 0 is 0. So for now, our concern is only this function. So let v is equals to pi times this function. So we need to simplify this one by multiplying itself. 2 to the 5th is 32 over 5 plus 2 to the 3 is 8 times 2 is 16 over 3, and then plus 2. So we have here the pi times this function. So we need to find what is the least common denominator of this function, of these three terms inside the one function. So we have here the denominator 1 of the whole number. So the least common denominator of 5, 3, and 1 is equals to 15. Because 5 times 3 is 15, 3 times 5 is 15, and then 1 times 15 is equals to 5. 15. So that's why the least common denominator is 15. So 15 divided by 5 is 3 times 32 is 96. Plus 15 divided by 3 is equals to 5 times 16 is 80. And then plus 15 divided by 1 is equals to 15 times 2 is 30. So for now, our v is equals to pi times this function. So let's simplify this one by adding 96, 80, and 30. So this would be result as a 15 over 15 and then 206. We have here pi, and then the volume is equals to this function. So for now, let's evaluate the pi times 206. So the result is 206 phi over 15. So this is already the volume of a given figure from our case 1. So the volume of our case, the figure of this from the case 1 is equals to pi 206 pi over 15. But we need to convert this one into a decimal so function. So let's v is equals to 206 pi, or pi 206 over 15 is equals to 43.14 units cube. So this would be the volume of this figure, that the axis of rotation is in the x-axis. So here, 43.14. So let's move to the second case, that the same function and the same limits of integration, but different of axis of rotation. Because here, the case 2 is find the volume of the solid obtained by rotating about the y-axis. So it talks about the rotation of y-axis, the region under the curve, and let x is equals to y squared plus 1, and then the interval is from 0 to 2. Let's have a graph. For the y-axis, or the rotation of y-axis, we have here the interval of from 0 to 2. So the rotation is in the y-axis. So let this curve here, that this would be the value of our radius, or the value of our x, y squared plus 1. And then let put this arrow rotate along the y-axis about 360 degrees. So what would be the result? So we can form a three-dimensional figure. So we have here, for now, we can calculate the volume of a given figure from our case number 2. So let's have calculate the volume for our case number 2. For the case number 2 is in the y-axis. So y-axis. This case number 1. Number 1 is in the x-axis. So we have here the x-axis for the case number 1. For the case number 2 is in the y-axis. So the formula, we have the v is equals to phi times the integral of f of y raised to the second power with respect to y. So we have already the value of our f of y, and also if forget this a and b, c to d. So the limits of our integration, we need to we use the variable c and d. So we have the value of our c, which is 0, and the d is which is 2. So the value of our f of y is equals to we have here y squared plus 1. So take note that x is the equivalent of x is equals to f of y. So the value of our x is equals to y squared plus 1. So let's evaluate the value of our f of y, which is y squared plus 1, and then the value of our c and d is 0 to 2. So this would become b is equals to phi times the integral of y squared plus 1 raised to the second power, and then we have dy here with respect to y, and then we have the lower and upper limits, so 0 to 2. At this moment, we need to isolate this one. So let's v is equals to pi, and then the integral of y is squared plus 1, and then times y is squared plus 1 with respect to y. We have here the 0 and 2. For now, y squared plus y plus 1, and then times y squared plus 1 is equals to, so let v is equals to pi times the integral of yx cubed to the fourth, because y squared times yx squared is y to the fourth. Y squared times 1 is equals to yx squared. 1 times y squared is equals to y squared. 1 times 1 is 1. So we need to put dy, and then we have the limits of integration 0 to 2. For now, v is equals to pi, and let's simplify the integrand by combining the like terms. So we have the y squared and y squared. So this would be the result of the integral of 0 to 2, and then we have y to the fourth plus 2y squared, because y squared plus y squared is 2y squared, and then plus 1 with dy. So for now, we can get the integral of this function. So what is the integral of y squared and then 2y squared and then plus 1? Sorry, y to the fourth and then 2y squared and then plus 1. So the integral of this function is equals to phi, the volume is equals to phi times y to the fifth over 5 plus 2y cubed over 3, and then plus y, because the function it talks about y, so we need to put as the antiderivatives of a constant is y. So evaluated 0 to 2. So for the rules of evaluation, we need to use the principles of definite integral. So let's 0 and 2 evaluate of this function by using the definite integral principle. So we have here the fb minus fa. So this would be the value of our b, and this would be the value of our a. So let's evaluate the value of our b, which is 2 of this function. So the volume now is equals to pi times 2 to the fifth over 5 plus 2 times 2 raised to the 3 over 3, and then plus 2 minus 0. Because if we evaluate 0 for this function, the result is 0. Because 0 to the fifth is 0 over 5 is 0. 0 to the 3 is 0 times 2. 0 over 3 is 0. Plus 0 is 0. So for now, our concern is this function. So we need to simplify this one. So 2 to the fifth is equals to 32. So the volume for now is equals to 5 times 32 over 5 plus 2 to the 3 is 8 times 2 is 16 over 3, and then plus 2. So at this moment, we need to get the least common denominator of these three terms. So we have here the denominator 1 of a whole number. So we need to simplify this one for getting the least common denominator. So for the least common denominator of these terms of this function is equals to 15. Because 5 times 3 is 15, 3 times 5 is 15, 1 times 15 is 15. That's why 15. So 15 divided 5 is equals to 3 times 32 is 96. And then 5 divided 3 is 5 times 16 is positive 80 plus 80. And then 15 divided by 1 is 15 times 2 is 30 plus 30 here. So for now, v is equals to pi, and we need to simplify this one by adding 96, 80, and 30. The result is 206 over 15, and we need to distribute pi to the 206. So the result is 206 pi over 15. So this is already the volume of a given that the axis of rotation in the y-axis with the value of our radius is y squared plus 1, and then the interval from 0 to 2. So the volume is 206 pi over 15, and let's convert this one into a decimal function. So this would be equals to V is, if we calculate this one, the result is 43.14 units cube. So this would be our volume of this figure that demand of our second case, or case number 2. So thanks for watching, and for more updates, please subscribe the PLANS 57 CFD in my YouTube channel.